Welcome to our new course lecture. If you were curious about whether in the Angular world, uh, there is some Redux features. So I presume you're familiar with Redux, with Flux, or with state management, and so on. And maybe if you were curious whether the Angular has the same features for enabling the store management or for Flux implementation? And the answer is yes. So today we're going to consider the how can we implement the Flux architecture in our app? How can we set up the store management? But first, uh, I propose to review the core principles of the Redux, of store management, in case you missed something during the React course. So let's get started. First of all, it's quite similar to the MVC pattern that stays for the model view controller. In brief, of what's going on within this model. So everything starts from the model. Actually, all these pieces has the single responsibility. For instance, controller triggers some changes within the model, and the view reacts to the model changes. As the user interacts with the controller sends some instructions to the model in case we need some updates. The model updates the view based on the payload, and the user sees all the upcoming changes that view has based on the updated model. This approach has some drawbacks. In case some views has to be include some models as the dependency to be able to work with it, it turns to the dependency hell, and you'll easily get lost in the architecture in case your application is so complex and depends on multiple models, views, etc. So in order to simplify the application structure, there is the architectural approach that is called Flux. Basically, Flux is the application architecture, which is developed by Facebook, and it's used to build the client-side web applications in that way that we can divide our architecture by parts. So these parts are the following. There is an action that contains the instructions. So what are we going to perform? The next one, the dispatcher, which sends this instruction right to the store, and once the store is updated, we're able to see the updated view based on the data that is changed in our store. So how it actually looks like. So yeah, this is the list of the popular Flux implementations. One of them is Redux. So Redux is widely used on the vast majority of projects. And today we're also going to consider the adaptation of Redux for the Angular. If you remember the previous lecture, we were considering the RxJS, the observables. So actually the adaptation of Redux for the Angular is based on the RxJS, on the subscriptions, and on the reactive programming in general. Well, basically, how this approach works. Let's refer to the to the following figure. Everything starts from the wish of the user. So in this slide, the user wants the number that goes in the middle to be equal 10. It tells the man that sits in front of the typewriter that we need to update that number to 10. Actually, this man is called the action creator. So it transforms the wish of the user into action, into structured action. So at the next step, the action creator forms our request in such a way that this request will go to the man with the headphones, which is called the dispatcher. So in the next step, the dispatcher sends the action directly to the store and tells that we're going to perform this action. Well, when the store receives the instruction, it's going to update the store data based on the action that is received from the dispatcher. And once the store has been updated, we'll see the updated result at the final step. Well, I suppose you're already familiar with the approach, but in case just for you to remember how it actually works. Okay. So as for the Redux, I'll already return to one of the most popular Flux implementations. The Redux is widely used in the React world and is successfully adapted to the Angular architecture. So as for Redux, it has some of the key principles that we're going to review shortly. These are the following. A single source of truth, data is read-only, and changes are made with pure functions. So let's review each of them. Single source of truth means that our application state is stored in a single place, and this is the object. So actually, our application has the single store for everything. If you remember the problem where you decompose your application and creating multiple components, there was a problem with passing the state for each component. So each of your subcomponents or parents, childs need to possess some piece of the state that is passed down to the children. However, in the Redux world, we store everything within one single state. So, and it's how it can look like. A single object for everything. Next one. The state is the object, which is called state, is immutable. It means that in order to update the application state, instead of changing some properties of its object to indicate that the state has been changed, we have to return the new object with all of the updates that we're going to imply. So it has to return the new object, because if we don't do so, the Redux will count the mutations. I would say it won't count any mutations because the store hasn't been changed. We didn't change the reference to the object, so it counts as the same state. So to indicate that the state has been changed, we need to update the reference to the object as well. All the reducer is the pure function. What does it mean? It means that depending on the arguments that are passed to this function, if we pass the same parameters to a pure function, it will result in the same output. In this case, the function is called pure, and all the reducers, the reducer is the pure function that is used to update our state, is the pure function. Yeah, so this is the explanation what the function, which function is called pure. So just for you to remember that putting the same input will result in the same output, and this function is the most important. This function should not produce any side effects. It means that it shouldn't call, well, it can call some dependencies in case that these dependencies are also the pure functions. Because in the second variant, well, what's going on in the second variant? Let's have a look. So this is the pure function because we are creating the new object. Yeah, it will result in every time a new object, whether in the first variant it mutates the existing card, and in that case, when we are performing some mutations, this function could not be called the pure one. Okay, so this is about the overview of Redux, about the key principles. And now let's review what the NgRx is. Well, basically, this is adaptation of the Redux with some of the RxJS features, plus it's wrapped by the ng modules, and as the outcome, the NgRx has been created. So this is the powerful library for the Flux implementation and the state management in general. So to get started, we'll need the following packages to be installed within our project. Actually, we don't need all of them, but uh, the most popular ones are the store, because there is no state management without store. We'll need to install effects, router store, to connect all the routing events with the store, and the store dev tools, obviously, to track all of the actions and state changes during the development. Okay, so what are the core concepts of the NgRx? Why observable? Because the RxJS features enable us to subscribe to the changes of the store and to reflect them as well. We have this in NgRx, we have the same reducers, and these reducers should be pure functions. So nothing new from this perspective. The actions also, some, well, I would say syntax changes will appear when we review how to create actions, but still the key concept is the same. So the action is the instruction of how can we change our store. Selector. Our state, the application state, can consist of the several properties. Let's say we have the single store for the whole app, and we need to store the information about the current user, about which let's refer to our TODO app at this moment. We need to store some information about which to-dos are loaded from the server, and any other entities. Well, if we wish to expand our application. So when we're in the, let's say, the to-do list page, perhaps we don't need to know about every property of our state. We need only part of it. So to achieve this result and get only the part of our state, we need the selector. And the NgRx has the concept of effects, which are the I would say the side functions, or even this is side effect model that is mostly used to organize the external communication. Let's in terms of network requests, some events, not only dumb ones, but if we subscribe to some WebSocket messages, so we can also react to them. So we'll implement all these concepts within our to-do list application. So, and if we consider the following scheme, all the core concepts are presented on the current slide. So if you want to, to trigger some action, let's say we are on the to-do list page component, and we want to mark the particular to-do as completed. First, we create the action that will produce some changes in our store. And once our store is updated, we'll, in terms of observables, as we have the active subscriber, we'll receive the new updates, and our components will reflect to the updates from the store. And at the same time, when we updated our store, we simultaneously trigger the effect that will produce the changes to our database. So we not only changed the we do not only make changes on the front end, but also we send a request to the backend that we've changed the state of the to-do. So we need to reflect these changes on the backend as well. So for now, need to understand that when we are dispatching some action, both store changes and the effects logic will happen simultaneously. But first, when you trigger an action, it will first imply changes to the store, and then the effects will be triggered. We will see in the practical example how the store management works in Angular. So we'll take our to-do list management app to implement and to adopt the store management architecture. So we'll set up our NgRx features, and we'll see how it works. So just a quick review. In the next steps, what we're going to do. First, we need to perform the import of the library modules and configure our stores, effects, and perform any other configurations related to the NgRx. So for now, we need store module and effects module. If you are familiar with the router module import syntax, you've seen the static methods such as forRoot and forChild. So here we have the same in terms of the NgRx. So in the app module, or even in the core module, if you prefer to perform all the configurations and library imports inside the core module, so you can do it. So here we perform some core initial configuration for store and effects. We provide the reducers. We list all the effects that will be triggered when we dispatch some actions. As for this one, we connecting the Angular router events with the NgRx, and this one enables the store dev tools in case we are in the development mode. In case we need to define some feature stores, and we can do it since we have the feature modules that are lazy loaded. And that's a cool feature because we don't need to configure the whole store for all of the features. Instead, we can configure the core reducers and then we're able to perform feature configuration within the lazy loaded module. It will work in the following way. Once the feature module has been loaded via the routing mechanism, the store will be also configured for the lazy loaded module. In other words, the features, the store features that are related to the lazy loaded module won't be loaded or configured until you navigate to the feature. I would say that the properties of the global store could be also lazy loaded as well. So let's get a deeper dive into the core concepts and see how can we implement the core concepts. So to create our action, we use the helper function that will do the job for us. As the argument, we pass the name of the action and to differentiate which property we're going to update. We are specifying the name of the feature between the brackets. Well, I guess this is the common practice and doesn't depend on the framework or library, so the vast majority projects do the same. So we're specifying the feature like in this example. If we need to pass some additional property into that action, we're passing as the second argument the interface for the payload. So payload is the value that is passed to the action during its creation. To dispatch this the action, first we need the dependency that is called store, which is injected via the constructor. And all we need is to call the method dispatch and pass the action to this method in such a way that, like, we are creating the instance of the action. I guess everything is clear. And of course, we need the reducer to define the structure of our store and the cases for each action to define how we're going to update our store based on this or that particular action. Oh, well, if you were been working with the Redux in the React world, so I guess nothing new for you, just some syntax changes. Okay, so moving next. So to use our store, we need a sort of selector that will grab the particular property from the global store and will deliver the state of a particular feature to our component. So once we define the selector, we use the dependency that is injected via the constructor to grab the latest state from the store. just to remind that this property of the component is the observable, not the pure object. Why observable? Because we need to reflect to the latest changes in case we change it by dispatching some actions. All right. And okay. Oh, well, let's consider the second block because this is the most preferable way to create the effect since the first one is deprecated. Okay, actually effects are the classes where we're defining the side effects for actions. Everything looks as in like we considered the RxJS features. So there is the new operator of type that will perform the filtering of the actions by its type. And in this case, when we dispatched the load movies action, it will result in triggering the movie service. And when the movie service has completed the loading of the movies, we will dispatch the load success action that will put all the movies to our store. However, in case of errors, we can easily handle it by the catch error operator and dispatching the appropriate action. Okay, well, I guess that's it from the theory perspective. Before we move on, do you have any questions? Okay, so now let's proceed to our to-do list management application to get started with NgRx. First, we need to install several packages. I'd like to install some of them. We can refer to the documentation and grab the command for the installation. So since our project is ngCLI enabled, we can add packages by listing it via the ng-add. That will perform the installation. We're going to add the store, DevTools, effects, and router store, but we're not going to use all of the features of it, but for you just to demonstrate the capabilities of the following dependency. So the package store will be installed and executed. So it doesn't support the bulk installation. Well, that's a pity, so let's install it one by one. Since we already started with ng-add. Yeah, that's cool. So the package will be installed. Store DevTools has been installed, but as for the rest ones, well, store hasn't been installed because of the errors. So let's add it. So we installed the DevTools. We also need the effects to organize the network communication. And let's install the router store as well and see what do we have in the package.json. Yeah, we see that we already performed the installation of the dependencies. So now we need to configure it. But since we installed these packages via the ng.add, it performs the initial configuration for us. So the DevTools module has been already imported, as well as the root configuration for the store and effects. Here we can define the list of reducers, and we already connected the router events with the store. Okay. In case we need some global store for managing the actions, let's say we need to show or to hide the spinner, so perhaps we need some core store for it. I propose to create this for us. All the store related files I suggest to hold in the store directory. For each store, we'll have actions, reducers, and effects. But as for the core reducer, maybe we don't need the effects. Well, let's say we want to have some core state, but before we need to create some reducer. So let's create the new one, app reducer.ts. So before we start, let's refer to the documentation to see how can we get started with the store. It had a quick walkthrough. So first we need some interface to define the structure of our store. We need a bunch of actions and the reducer to react to that changes. So let's define the structure of our state. This is the app state. Let's say we want to have some flag for indicating the loading process. This will be the Boolean. As well, it will be good to define the initial state. And we're going to create the reducer for us. And to create the reducer, we're going to perform the following. We're creating a reducer, passing the initial state for now, and we need to define some cases for actions. So let's create at least one of them. App actions.ts. We're going to create the new action. Let's define the namespace, set load, set loading state, and we need to define the structure of the payload that will be passed to that action. To do so, we need this one. So we're going to pass the single Boolean okay. So what's going on? Understood. Okay. So are we able to do the following? So we don't have. Okay. So we'll pass as the following. So we've created our action. We're going to pass the Boolean to indicate whether we need to show the loading spinner, to indicate the progress of loading and so on. Okay, so we are defining the case that on this action we'll update our store accordingly. So at the first argument we pass the action, on the second one the callback that will return the state. Just to remind that it must be the new object, so the state is immutable. And since we have some payload, so we'll have two arguments. First is the current state, and the second one is the payload. We're going to destruct it, and set is loading here. So we've created our first reducer. Well, let's connect it to our root store. Our feature will be called app, and let's say with its key, we're going to import the app reducer. Okay. So let's try to run our application to see whether we will able to see the app store on the store DevTools. So let's have a look. Well, maybe it will be good to start our JSON server. So let's see. No store found. That's kind of interesting. Wow, that's not what I was expected. So maybe we missed something. Let's have a look. But still, we created the reducer. Um, okay. So let's find out what's going wrong. Well, we don't need any configuration right here. So maybe I missed something. Let's have a look. Yeah, we define the reducer within the app module. So for now, we don't need any selectors, some actions. Okay. So maybe we wanted the look only, but let's try to do the following. So maybe we enabled the DevTools incorrectly, but still I don't see anything. Okay. Well, at least let's try to perform to create at least to dispatch it at least the action to see whether we're able to react to the changes, and then we will see the result. So we passed the initial state. Yeah, our initial state is the following, and we should be able to react to it, but we don't see any changes. That's kind of weird. Okay. In this case, we'll do the following. Let's create the feature store. This feature store is our TODO module. Let's create a store for it and several directories: actions, reducers, and we will have the effects. So first we need load TODOs. And action for success and for failure. As for success, we need some payload. And let's create another one to toggle the completion status. Okay, we created a bunch of actions. Let's just refer to our app reducer. So we'll have the state for the to-dos. We need some cases to reflect to the changes. We're going to put below the to-dos. And to toggle the completion status. Well, let's refer to the to-do list to see how we perform the toggle. Yeah, we basically pass the item. So we need to change the entire array to create the entire array. Start into, in case if the ID is equal to that item that we are passed as the payload. Well, we have the is completed property. We're going to update the completion status on UI before we send the changes to backend, because all the network requests can take about 2 or 3 seconds, and to create a smoother experience, the good practice is to update on the UI. In case of failure of the toggling, we can create the action for the failed state to reset the state of the to-do. Okay, well, let's try to enable the feature name to-do. Well, just for you, in case if you want to say something, just unmute, because sometimes I don't see the chat. So we're going to use this reducer to register the feature store. And we'll add the effects shortly. Maybe I missed something because I want to see the changes on the DevTools. Okay, DevTools. So let's see if everything is help allocated to module. And so this the installation and everything is restrict extension to locally in the production mode, and that should be it, but I don't see anything. Okay. Let's define some effects for the to-dos. So for now, I'll have two of them. First, we'll fetch the to-dos once I dispatch the load action, and the toggle will also perform the network requests. Well, as I said, effects are actually the class we're going to inject some necessary dependencies. Actions, which is the observable where all the dispatched actions are pushed. And we need our service to invoke its methods. Okay, so let's define our effects. For everything that is observable or asynchronous subject, I propose to use the dollar at the end of the naming. We're going to create the new effect. Refer to the observable actions to grab the particular action, but first let's import it. Let's import every action for our convenience. So this effect will be called on load to do's action. And since we want to deal with the network request and we need to wait until the request will be finished, we need to use this switch map operator because we need to subscribe to the inner observable. As I've mentioned during our previous lecture. And all the effects should return the action to be dispatched to the store. So in case of the success scenario, we'll dispatch the load success action with the payload to do's. Okay. in case of error, we need also to handle this case. For now, just dispatch the error action. And since the cache error should return the observable, we just do the following. Well, okay, we've created our first effect. Let's create another one for toggling to-dos. To the service, toggle complete. Here we will just pass the changed item since we will change it. No, actually just leave as this because otherwise it won't work. Okay, we don't need to wait for this request, and we don't need to dispatch any of the actions. We just need to call the service, right? But it says that something is wrong because it's awaits that we will pass the typed action to be dispatched. In case we don't need to dispatch anything, we'll pass the following configuration. We just need to perform the network request. All right, so we have the actions, the effects, reducer, and we can use it in our code. But first, we need some selectors. We need to create a bunch of selectors. So first, we'll refer to the name of the feature. Well, basically we can do the following. So the selector could be the regular function that will return the property that we want. But I recommend you to use the create selector or create the feature selector. Just because selector can hold the latest value, the latest state, and it can memorize the state of the reducer. So it's kind of powerful, and also it's possible to combine the selectors into the single one. So each selector will contain the following. So first we use the existing selector, and then we do the following. We return memorize selector. Okay, we just created. Maybe that's. Maybe that's because we didn't specify the generic for it. Okay, we have selector. So now to use the store, we'll do the following. First, we import everything from the reducer file. And so we'll do like the following. Store reducers to do reducer. And we'll inject the store as the dependency. And instead of having the array, so first we don't need to have this one. We're going to re-implement this method. On add to do, we need a separate action. First, we need to instead of calling the to-do service directly, to dispatch the correspondence action. Here's how they load to-dos. Okay, since we missed something, to-do list, let's say for now it will be the observable of the to-do items, just because the store is the observable. To grab the latest state for the to-dos, we're going to use the selector that we've created. So to-do list has no initializer. Well, let's create this one in the constructor. So since we don't have the to-do list right here anymore, I would use the async pipe. What's going on? Async missing require statement. And I don't need the require statement because async pipe is the default one. So maybe I'm missing. No, command module is already imported. The null is not assignable. Okay. To do item. And why is it null? Well, for now it's the observable. I'm curious why the async pipe doesn't work. Maybe it's because the Friday evening and everything won't work unless I end the lecture, but still. Well, since the async pipe won't work with us, so we will do the following. So the to-do list will be array as initially, but instead we will do the selection of the to-dos and will subscribe. So it will load to this for us. Well, okay. So we'll initialize it with the empty array. So let's see whether it will work. Okay, we see that even the request isn't sent to our server, but we dispatch the action. Okay, I presume we need to dig deeper and find out why I don't see the store. Maybe I missed something, but I'm not quite sure. So let's kind of walk through. So we've created the reducer. As for the TODOs, we also have the initial state for it. We initialized it, the feature reducer as well. So let's find out what we've missed. Store module. The reducer is created. Declarations. NgRx store. Okay, we have the store module. Okay, we see that it redirects. It redirects because can't resolve all parameters in TODO effects. What are they? Actions and TODO service. Okay. Let's comment it for now and see. Aha. I know what's going on. That's because the effect should be at least injectable and because this actually the service. Okay, now I see that At least we have the request to the backend. Well, unfortunately, I don't have an idea why the DevTools don't work, but at least we managed to grab the TODOs from our JSON server using the NgRx. As we can see, we selected it from the store. Let's try to test this feature out. We need to dispatch the action toggle to do. Pass the to do to the action and see what the result will be. Okay, we see that the request was sent, and if we refresh the page, everything will work pretty fine. So we see that to-dos are updated. And the result is the same. Okay, I propose to create some other actions. So what's the contract of adding the to-do? Well, let's refer to the to-do service, add to-do. Okay, it accepts the to-do as well. So the add to do will send the request to the backend, and in case of success result, the to do will be added to the whole list. Let's create a bunch of actions. Here we won't have any props. Okay, so let's update our reducer on add to do success. We're going to add the new item in this way to make everything immutable, and we need the new effect that will trigger the add to do on the backend. Add to do, we need to take the payload add to do success and add to do failed. And to make everything work, we just need to dispatch this action, add to do, to make everything. Kenzie will rename the property. So let's see. Yeah, as we can see, new item has been added and everything works as expected. Uh, okay, so as for today, not everything will goes well. You should remember that this is the live coding actually, and something can go wrong. But still, we managed to set up the NgRx to make everything functional except the dev tools because something goes wrong with it, but we'll find out. Okay, as for the root reducer, we created just for test to show you that we can have some root store for everything. Let's say for managing the state for UI components, for spinners. So we can use the reducers actions for this store and for to-dos as well. And if we create the new feature module or we wish to create the new reducers, so we will achieve the same result in the same way. Well, I guess that's everything. We will not get so deep into the details and advanced practices. I guess for now that should be enough. How to get started with NgRx, with Redux. Yeah, there are a lot of features actually, but as for the beginning, I guess that should be enough. Okay, before we wrap up today's lecture, are there any questions so far? So I want to ask me something. All right, if no questions for now, but still, if any, so you can reach me by all means. Thank you for your attention and see you next week.